Now that we have a graph using three different symbols, let's talk about how to add a legend to this graph to describe what these three different symbols mean. If we go back to our code, we can use a function called legend to add a legend to a base R graph. You can see the first two arguments to legend are x and y, which are the x and y coordinates where you want to put the legend, as well as a lot of other stuff in terms of options of how you populate this legend. The next important thing being the legend, which is the text that actually goes in the legend that describe each of the symbols. And then you're also going to have somewhere in here a PCH option to tell it which symbols that you're describing for the legend, which I'm not seeing. Oh, there it is, PCH. So we can add a legend, and I like to do that at the end of the code that's creating the graph. So here after the title, before my dev auth that actually creates the PDF file, I can add my legend. And this is also one of the benefits of breaking down your plotting into all of these separate calls rather than just using a call to plot. Namely, I can recall this plot.window that I called up here to establish the coordinate system and create a coordinate system that's a little bit easier to think about for putting something relative to my graphing area. I don't really need to think in terms of the coordinate system I'm using to plot my data to want to put my legend on the graph in the same place every time relative to the shape of that graph. So in that case, I can call plot.window again on the same graph and reestablish the coordinate system. And in this case, I'm going to use a very simple coordinate system where my extremes and my minimum and maximum for my x-axis are 0 and 1, and the minimum and maximum for my y-axis are also 0 and 1. Now I don't have to think about the numbers that I'm plotting anymore. I just know that something halfway up the graph is going to be at 0.5, and something halfway across the graph is going to be at 0.5. So I can put things relative to my axes without having to worry about the original coordinate system I used for the data. That just makes it easier to think about where things are going to go when I call functions like legend. Now I happen to know we're going to need a lot of arguments to legend, so I'm just going to go ahead and break this into several lines of code. And the first argument we need is going to be x. So let's just say, if I go back to my graph, we've got some room over here. I want to put my legend on the right side of the graph. There's more than one way to do it, but based on the coordinate system, I might say, well, the right side of the graph is where x equals 1, because I'm going from 0 to 1 across my graph. And likewise, 1 would be at the top of my graph for y, so I can do a y equals 1. So remember, I've rescaled the axes from 0 to 1 on the x-axis, 0 to 1 on the y-axis, so I'm thinking about this upper right corner by making both of those 1. So let's see where that gets us. If I rerun this, oops, I've got an error somewhere. Legend is missing. Oh, I have not provided a required argument. So I need to give it a legend. I need to give it a value for the argument of legend, or the function can't operate. So you'll see this message argument legend is missing with no default. If a function you're calling has an argument and you don't provide a value and it has to be there for it to work, this is the error you're going to see. So for now, let's just put in just some text so we can get a feel for how this works. So I'm just going to put in the word blah. Now it runs and I can bring my PDF back and you can see, well, there's something up there in the upper left, but it looks like it's going off the edge of my plot. Now this is something that you're going to see when you use a function that's designed to put something within the graphing area, in other words, in this box where we're putting all of our data, then there's an argument or a graphics parameter called XPD that masks everywhere outside the graphing area so that even though we're putting something there, we can't see it because it's going off the edge of the graphing area. And you can control that. you have the ability to set that graphing parameter. And in this case, we can set that graphics parameter directly in our call, our function call to legend. So I'm going to add a parameter here, call it xpd. And we can look at the graphics parameter xpd by calling the par function. Remember, that's how par is how you look at graphics parameter values. And we specifically want to see the value that xpd is set to by default. And you can see it's set to false by default. And false means don't print stuff outside of the graphing area. If we wanted to allow it to print stuff outside the graphing area, we want to set that to true instead of false. So when I call legend, I'm going to set an xpd argument to true. If I run this again, we can see, now we see more of the argument. We can see the BL of blah. We can see what's off the graph. But now we're actually running off the edge of our canvas. Well, that's probably because 1 is in this upper left corner. Remember, there's a 4% buffer, so there's 1 is somewhere in the upper right corner, and it's probably here in the upper left corner of our legend. So that means when we give it 1 and 1, it's telling it where the upper left corner of the legend is. Now, we can fix this by setting our x value to something less than 1 and our y value, well, maybe the y value is where we want it to be, but our x value is something less than 1. But we can also tell it, well, where to put the legend relative to those coordinates. And that's another set of arguments. It's the x just and the y just. And I find it easier to think about just changing the justification because I like pinning at 1, 1 because I know exactly where 1, 1 is. But I want to reshape the legend however big it needs to be to fit in it, but I want the upper right corner of the legend to be defined at 1, 1. So I can set the x just to 1, and 1 tells it to put the edge of what I'm calling 1 for the x to be on the right side of the legend instead of the left side. So by default, it's 0. I want to set it to 1 so it's on the other side. And I'm going to leave y just at 0, which is where, I think 1, which is where it is by default. Let's double check that here. No, y just is 1 by default. So I'm going to leave that at 1 by default. Here's x just at 0 by default, but I want to set it to 1. So I'm leaving y just where it was at 1, but I'm changing x just from 0 to 1. And now I can see I've moved it over. It's still at 1, 1 is my reference point for my legend, but now that's the right side of my legend because I changed the x just to 1. So the reason I like to do it that way is I know exactly where 1, 1 is when I set up my x lim and y lim the way I am for this legend. And I would rather tell it, well, here's where I want the legend to be. And that's just because this legend might get bigger or smaller depending on what you put in it. And you don't want to have to keep changing where you're putting the legend every time you change what's in the legend. You want it to scale this way if it needs to get bigger and always be here in terms of where it's anchored. So with that in mind, let's think a little bit more about what belongs in this legend. I'm going to go back to my plot here. And I want to collect information in my loop that's creating my graph. Each time I go through the loop and call points, I want to collect some information about what's being plotted because this is where it's plotting the different symbols based on the plot. And those symbols correspond to a different initial concentration. So I can actually collect the value of that initial concentration each time I go through this loop and make that the label for that loop. So in order to do that, I'm going to need a vector of values that I call labels. I'm setting this up before the loop because like before, I want to build the data structure before the loop that's the right size to hold everything I need, and then I'm going to fill in that data structure with my loop. So I'm going to go call this labels, and this is going to be an atomic vector of character strings. So to create a vector of character strings, a blank vector, I can use the character function. That's a constructor for creating a character string. And I need to tell it the length. In this case, the length needs to be, well, again, however long my results are. because I'm looping through results here. And I need this to have as many different character strings as I do results or elements in my results list. So now I have a labels vector of character strings that I can fill in as each time I go through the loop. And then each element indexed by this const index variable that's changing each time through my loop. I can set one of the elements of my labels vector to the results in the rate, I'm sorry, not the rate coefficient, the initial concentration. And I've called as character on this because this is a number. Result $const init is a number, and I want to turn it into a character string that then goes into this element of labels. So I create a labels character string. Each time through this loop, the index is going to increment from 1 to 2 to 3. And I'm going to therefore set the first, second, and third element of labels each time through the loop to the corresponding const init that corresponds to that time through the loop. Now I'm going to have some character strings that correspond to each const init each time through the loop. I can go back to my legend and change it from blah to that vector of values. So I'm going to change this to labels. And therefore we can see how this all works. Now instead of having just one character string that I put in there that was blah, I've got a vector of 3 character strings. Let's see what that does. Now I see I've got 100 for all 3, so I've done something wrong because I have the same value for all 3. Let's take a look at what's going on. I can confirm that labels is a vector where they're all 100. Each time through its const index, so I am incrementing that. Here we go. I've forgotten my index here. I've got result, but I need the specific results. I don't have, yes, result is coming from earlier up. What I actually need to do is something just like this. I need the specific result indexed by const index, which I'll get to using results const index. So that should fix my problem because now I am getting each time through the loop, instead of using the same result every time from up above, I'm using the specific result based on indexing the results by the variable that's changing each time through the loop, and then pulling out the initial concentration from each of those. Let's try this again. And there we go. I fixed the problem. I've got 25, 50, and 100. Now I'm missing the symbols, so I need to put the symbols in there that correspond to those. Well, I know what those are already, right? That's just my PCHs. So, excuse me. If I go back to my legend, I've got the labels now. I need to give it another vector of PCHs that correspond to those labels. But I've already created that. This PCHs was created up here as part of defining the PCHs that go with each one of the results. So these two vectors need to agree with each other in terms of their order. The 3 elements of the labels need to correspond to the 3 elements of the PCHs, and I've set up my code so I know that's true. I can run this one more time. Now I see I've got 25, 50, and 100. I can do some aesthetics here in that I don't really want this box around here. That's just something that I don't like to do with my graphs. So I want to get rid of that box, and it turns out there's an argument for that. You can see here under legend, under the help, you will find a BTY option, and that's box type. So I'm going to add a BTY argument, and I know that if I give it the character string n, that means no box. So again, I can rerun this, and sure enough, the box has disappeared. So BTYN has gotten rid of the box around my legend. Now, finally, these numbers are great, but what are those numbers? There's no reference to what these numbers correspond to. So what I need to do is give myself a title to my legend that tells me what these numbers correspond to. So I'm going to go back to my code one more time. And I want to add a title argument. And you can find the title argument over here in the help. And the title is going to be, in this case, I want to use some math notation. So as I've shown before, I want this to be an expression. And I find these a little easier to read if I just break this into multiple lines so that I can see the expression here. Now, the values are the initial concentrations, right? So that is a C naught. And this is mathematical notation, so if I want that naught to be a subscript, I need to put it in square brackets. So I'm going to put a capital C, a 0 in square brackets, so that's a subscript to the capital C. The next term in my expression, I want to put some units here. So I'm going to put some space between that C naught and the next thing. It's going to be units, so I'm going to put that in parentheses. It's pretty common to put units in parentheses. So a parenthesis by itself, I can't do this because a parenthesis is a special character in plot math. So I don't want it to treat it as a special character. I just wanted to put the parenthesis there rather than trying to interpret it. So I need to put quotes around it. Then the units, in this case, are milligrams. I need some space between my milligrams and per liter. And then an L, capital L for liters. And then I need a superscript of -1 to indicate a per liter. Then I need my closing paren. And that's the end of my expression. So I've got a C naught. I've got an open paren, no space, milligram, some space, a liter per liter, no space, closing paren for my expression. So plot math, again, if you want to check the codes for plot math, you can do a help on plot math to talk about all the different things you could do with mathematical notation. And let's see what that looks like. So I've got C naught with a C, a subscript of 0, and milligrams per liter in parentheses for my units, telling me what each one of these numbers means in terms of its units and the variable it's representing. So that's my initial concentration, 25 for the circles, 50 for the triangles, 100 for the plus signs. Now there's one last thing I'd like to do, and that's frequently when I'm making a graph where I don't necessarily know where all the data is going to be, I like to put my legend outside the graphing area. That way I know that my legend is never going to collide with data that are plotted within the graphing area. So let's think about putting this legend in a different place. Right now we've got it inside the axes. Let's say we want to put it over to the right here, outside of our axes. And let's say we want to put it in the middle relative to the y-axis, but outside of the axis relative to the x-axis. Let's think about how we might do that. Well, we've already got xpd equals true in here, so we know we can put stuff outside the axes. We don't need to change that, but we do need to change where the legend is going to go. So in this case, in the x-axis, I need to put it off to the right. Now I know that the very edge of the x-axis is going to be at 1.04, because remember there's that 4% buffer of the size of whatever's in the graph, which is from 0 to 1, that's being put by R on all the way around the graph. So I know that the edge of the graph is actually at 1.04. So let's just say I want to put off to the right, somewhere beyond that right edge of the graph, and let's call that 1.08 off to the right. Also, I know that I'm going to need more room over there for my margins. If we go back to the top, remember we called par and set the MAI argument, or the default value for the MAI graphics parameter, 2 different values to establish the margins, and we've only got 0.2 inches available in the right margin. So this is the bottom left top and right for these 4 different values. And 0.2 is probably not enough space. I mean, we can just look at it and see, yeah, there's no way this is going to fit here. So we need to create space for it. And we can do that by making this much larger. Let's call it 1.5 inches to make sure we have enough space. So now we've got space on the right for our margins. We're putting our x-axis to the right. And now we also want to change our x-just, our justification for our x. If we go back here, we're setting this because we want the left side of our legend to be at 1.08. That's the idea here. So now, instead of using x just equals 1, I'm going to change this to x just equals 0. Also, I want to put this at the center of the y-axis, and I also want to center the justification. So basically, if I want my legend, the center of my legend to be at the center of the y-axis, this is the configuration that I need. I need to tell it, go on the axis, on the y-axis, the location of the legend is 0.5, and center the legend on that point on the y-axis by using a y-just of 0.5. Okay, so we've changed where the legend's going to be. We've changed the graphics parameter for MAI to make sure there's room for it. Let's see what that does. So now we've got extra space in the margin. We can see we're centered on the y-axis, and we are just off of the x-axis by 1.08 in this case. And you can play around with all of those different values to see what that does to shifting around where this goes. But again, it's really nice to have a concrete place, 1.08, where this is always going to be. And if you need to adjust relative to where that's going to be, you can use the x-just and y-just to shift it around. So that is an example of how to make a legend. Oh, there's one more thing that we can do here. Technically speaking, when we're doing math, variables like C0 are supposed to be italicized. And we can actually do that. We can go back to our code. In plot math, if you look around, you're going to find a particular function in plot math with italic, called italic, that will allow you to italicize stuff. Italicized text that you're putting in, or as I should say, italicized mathematical notation that you're putting into the graph. So if we want the C0, or at least the C part, to show up as italicized, then I need to put italic C, italic function around my C0 to italicize the C. Now I don't think it's going to italicize the 0 because it's a subscript, but it will italicize the C. But that's pretty normal for mathematical notation. If I run this one more time, you can see now that it's italicized. So I've got an italic C, and that's more proper mathematical notation for a variable. It should be italicized. So now we've got a legend that is describing what these different symbols mean numerically. It's saying that our C0 is 25 for the circles, a C0 is 50, and a C for the triangles, and the C0 is 100 for the plus signs, which all make sense relative to our exponential decays.